Hi students, let's look at this question here, which is a common question and a common misconception that we need to address, which is to express the following complex number in some form of cosine theta and I sine theta, or I cosine theta and sine theta, into the form of z equals r e I theta. Okay, so the first thing to understand is actually it has to be positive. R is always a positive real value. Okay, and theta has to be between, this is a principal argument, we know that. So, and also to know that usually in this case what we need to know is actually ei theta is actually cosine theta plus I sine theta, or rather e ei a, or rather alpha, is cosine alpha plus I sine alpha. Okay, and that it has to be the same alpha. And also the trigo ratio, that the trigo identity that we like to use is sine theta. Negative sine theta is equal to negative sine negative theta. Then cosine theta is actually cosine negative theta. Okay, so these are the few things you just need to take note. These are the three things, the main ingredients needed to do this kind of questions. Okay, so let's look at the first one. Okay, so this okay, I know that sometimes we forget how do we get that, but just remember that for I sine theta, it is all ASTC here. So if we have got negative theta and theta here, we know that cosine theta here is positive and cosine negative theta here is positive. Okay, then sine theta here is positive, whereas sine negative theta here is negative. That's why is negative, is sine negative theta is actually negative sine theta, whereas cosine theta is cosine negative theta. So I think that's pretty okay. So these are the three things you just need to take note. Then what we need to do next is essentially just try and form into this form here. So let's look at the first one. The first one is essentially cosine theta minus I sine theta. Okay, now before we can express in ei theta, we must understand that the I is attached to the sine. Oh yeah, I is already attached to the sine, so this is pretty okay. Then after which, the next thing is we need to be able to, and this has to be a plus, so it's cosine theta plus. So what I'm going to do is actually just going to use this second function here, which is to absorb the negative in. So cosine theta is plus I sine negative theta, sort of it. And just know that for cosine theta, the angle can just change to a negative here, so plus I sine theta. So this first case here, we know that cosine theta minus I sine theta is actually just e I negative theta. Okay, because we get it. So for part 2, on the other end, we have sine theta minus I cosine theta. Now this one is slightly interesting. The rationale is because now that the sine theta doesn't contain the I. Okay, so what we're going to do is actually, if we want to force the I to be with the sine theta, because the I sine theta has to be the I, this is the cosine with the I. So what you need to do is actually just manipulate it by multiplying with the I. And if you multiply top with the I, bottom has to multiply with I as well. So I think that's pretty okay. Then the top will just be actually what we can do is just sine theta I minus I squared cosine theta. There's I here. So I can multiply I again to rationalize the denominator. I could do that, or I can just change it to exponential form. So let me just show you. So this will be positive. So it's I sine theta. This will be negative. So this is positive cosine theta. We know that I is here. I is actually in exponential form. I is actually ei pi over 2. So essentially here, what you get from the top is cosine theta plus I sine theta, which is what we want. The bottom here is pi over 2. The top will be ei theta ei pi over 2. So by using the rule of indices, shouldn't be an issue. Will just be the theta divided by ei theta divided by ei pi over 2 will just be the power just minus of each other. Okay, so that is part 2 done. Yep. So we're going to look at part 3. So I'm going to do all of this, so we just slowly look at it. Part 3, we have minus sine theta plus I cosine theta, so I think this is pretty okay. So for part 3, we have minus sine theta plus I cosine theta. Remember that we need the I has to be with the sign, right? The I has to be the sign. So actually it's the same thing because now it's just the flip of the other one. I could just do I just extract the negative out. So this is negative sine theta. Positive. Just factorize the negative out. This will be sine theta minus I cosine theta. Right, so from 2, we know that sine theta minus I cosine theta, if you were to do the steps there, will be EI theta minus pi over 2, right? EI theta minus pi over 2. Then what I'm going to do is actually just replace this in. There's a negative 1 in front here because I factorize this out. So just remember that negative 1 is also in exponential form. So if you draw the Argand diagram, negative 1 here is 1. This is pi. So negative 1 is EI pi. Okay, so EI pi. This is EI theta minus pi over 2. Then just add them up. Plus pi. This is this adding with this one, right? That will be EI theta plus pi over 2. Okay, that is part 3. Done. Then what we're going to do is part 4. Minus I sine cosine. Oh, is it the same? Somewhat. Okay, then I'll just copy it down. Part 4. Part 4 we need is minus sine theta minus I cosine theta. So what I'm going to do is this I doesn't have so I need the I in front of the sign, right? So same thing, I would get this out by multiplying with I'll just multiply top with I, bottom with I. Okay, then I'll multiply in the base minus sine theta minus I square cosine theta over I. I know that I is equals to this I here, EI pi over 2, which we already discussed just now. So this case here will be minus I sine theta. Then this will be plus, because it's negative, cosine theta over EI pi over 2. Now the thing now here is essentially there's a negative here. So this negative can just absorb in, just like what we did just now. So this is I sine negative theta, but we can't leave this cosine theta as positive because the what do you call it, the angle has to be the same. So I'm going to use this formula here where cosine theta is equal to cosine negative theta. For cosine, you could just introduce the what do you call it, the angle to a negative angle as and when, whereas for the sine you could just bring out the negative out and in of the function there. So this case there, EI minus theta, EI pi over 2. So this case here we get theta minus I pi over 2. I'm going to rewrite this out as E minus I theta plus pi over 2. Okay, so that's how you do this question here proficiently. If you have any questions at all, please let us know and I'll see you in the next question.